Okay, so we're going to solve compound inequalities. This is the second lesson on this topic. And you'll notice that in number 1 that we have here 2x plus 1 is less than or equal to 4x minus 3, which is less than 2x plus 5. Notice that this compound inequality looks different than the one we did in the previous lesson. And here's how they're different. You see, remember the compound inequality, there are 3 parts. You have the left, the middle, and the right. Notice that in between, the difference between this and this is that on these that we're going to do, you have variables that are appearing on the outsides as well. And in all the other problems that we've done in the previous lesson, the variable only appeared in the middle part. So in every one we've done, if you go back to all the problems we've done, the variable only appeared in the middle part. Okay? And so that's the only difference. The process to solve all of them, though, this as well as this, can be done by splitting it apart into 2 simple inequalities with the word and. And remember from the previous lesson, that word and means intersection. So that's why you saw we looked at where those 2 graphs, those 2 simple inequalities, where the graphs intersected. All right? So that's going to be the same approach. So let's go ahead and start doing this. So just like in the previous lesson, we're going to split this compound inequality into 2 simple inequalities. So we said, and you can cover this part up if you want to, so 2x plus 1 is less than or equal to 4x minus 3. And at the same time, cover this part up now, 4x minus 3 must be less than 2x plus 5. All right? So the solution to the original compound inequality can be found by looking at the solution of each of those individual simple inequalities and looking at the intersection of those 2. All right, so let's go ahead and solve this simple inequality. So since 4x has a positive coefficient here, I'm going to go ahead and subtract 2x from both sides. So let's bring all the variables to one side. So notice those are, in all the problems we're going to do, those are linear inequalities. So those are easy to solve. 2x minus 2x is 0. 0 plus 1 is 1. So remember that's 0 here. Combine like terms. And we get 1 is less than 4x minus 2x is 2x minus 3. Then adding 3 to both sides, I got 1 plus 3 is 4. So 4 is less than or equal to 2x. This is 0. And now to get x by itself, we're going to divide both sides by 2. So I get 4 divided by 2 is 2. So 2 is less than or equal to, and then that's just x. So what I found, what this right here means, is that the solution to this simple inequality, not the compound, but just the simple one, is any number, any real number that is greater than or equal to 2. So remember, 2 is less than or equal to x, means the same thing as x is greater than or equal to 2. All right, now let's go to here. I'm going to do the same thing. I'm going to go ahead and bring the variables to the left-hand side. So I can subtract 2x from both sides. So remember, what you do to one side, you have to do to the other. You have to show that everything you write has to be mathematically correct. If you do it once here, you got to do it once here on the other side. 4x minus 2x is 2x. Minus 3 is less than, and then that's 5. Adding 3 to both sides and combine like terms, I get 2x is less than 8. Divide both sides by 2. I get x is less than 4. So the solution to this simple inequality is any real number that's less than 4. So any rational number, any irrational number less than 4 is a solution here. So there's an infinite number of solutions to this simple inequalities. And there will be an infinite number of solutions to this compound inequality as well. Okay, so to find the solution to this compound inequality, the solution to this compound inequality is this. It's any real number greater than or equal to 2. I'm going to go ahead and graph that. So put 2 and 4 in the number line. Make sure you write them in numerical order. All right, so 2 is smaller than 4. Make sure you put that in numerical order. So any real number greater than or equal to 2. So notice I'm graphing that part. Notice the closed circle because of the equal sign. 2 is a solution to this inequality here. And at the same time, hence the word intersection, and at the same time, any number less than 4, like that, open circle. And so the solution to the compound inequality is the intersection of those two graphs. And so your graph, so the answer, you're going to say the graph, it's going to be asked to graph this. So the graph, make sure you put it in order, 2, 4. At 2, it'll be a closed circle. At 4, it's an open circle. So close, make sure it looks closed, make sure it looks open, and then shade every real number between them. No arrows, all right? There are no arrows here because you're bounded between 2 and 4. The interval notation is easy as well. Interval notation, bracket, since 2 is closed, you'll put bracket 2, comma, all the way to 4, parentheses. All right, so your solutions are between 2 and 4, including 2, but not including 4. And then the inequality, to write your solution as an inequality, you're going to, your variable is x, make sure you use the variable x. So you're going to say, so all your solutions are between 2 and 4, right? So x has to be less than 4, and at the same time, x has to be greater than what? 2. So 2 is going to be the smallest. 2 is the smallest value in your solution. So 2 is less than or equal to x, and at the same time, x has to be less than 4. So make sure you write this correctly. Don't put a greater than sign here, because 2 is not greater than x. X is greater than 2. So be careful how you write this. Remember, when you write it as a compound statement, the inequality symbols must be in the same direction. All right, so that is number 1. Now remember, the other way to do that is this way. So you may say, well, can I do it the other approach like I did in the previous lesson? All right, now let me explain when you can do that. Do you see that on the outside the variable terms are identical? 2x, 2x, right? 2x, 2x. They are identical. So notice the variables appear on all parts. The variable appears on all parts. If the variable on the outsides, if that variable term is identical, they are the same, then yes, you can do it the short approach as well. So let's go ahead and do that. So here is number 1 again, and we're going to do number 1 using the short approach, the other approach. So we're going to rewrite this over. Okay, so let's go ahead and do that other approach. Okay, so again, you can do that short approach only if on the outside the variable terms are identical. 2x, 2x. So now what I'm going to do is I'm going to get rid of those. I'm going to subtract 2x. I'm going to subtract 2x. So 2x from the right side, 2x from the left side. And what you do to these parts, you have to also do to the middle part as well. So subtract 2x, subtract 2x, subtract 2x. Mathematically, you have to say, if you do this here, you have to do it here, and you have to do it here to be mathematically correct. Then we can combine like terms. 2x minus 2x is 0. 0 plus 1 is 1. Is less than or equal to. 4x minus 2x is 2x. Minus 3 is less than. This is 0 and 5. And now this becomes very simple. This right here, so I went from this compound inequality that had variables in all parts to a compound inequality, to an equivalent compound inequality that has variable only in this part. So it now looks like, if you go back to the previous lesson that we did, it now looks something like this. Okay? All right. So now let's go ahead and isolate the variable in the middle. So we're going to add 3 to all parts, just like this. 1 plus 3 is 4. It's less than 2x. This is 0. It's less than 8. Okay? Then to get the variable by itself, we're now multiplying by 2. The opposite is to divide by 2. So I'm going to divide all parts by 2. 4 divided by 2 is 2. It's less than or equal to x is less than 4. And notice your solution to the compound inequality is any real number between 2 and 4, including 2, but not including 4. So any real number is a solution. So there's an infinite number. There's an infinite number of solutions. Notice, though, that when we did it this way, this solution is the same that we got here when we did it the other way. Okay, see this right here? All right. So this is your inequality. So you wrote your solution as an inequality. Now we're going to write it, we're going to graph it. So the graph, make sure you put it in order. So 2 comes first and then 4. So 2, 4, close circle on 2 because of the equal sign, open circle on 4 because there's no equal sign, and every real number between them. There's an infinite number of real numbers between those two numbers. So there's your graph. And then interval notation, interval notation, you say bracket, 2 to 4 parentheses. So that's interval notation. So whenever you see closed circle, that's bracket, open circle is parentheses. All right, so there's number 1. Okay, so that's number 1. Now let's look at number 2. So in number 2, let's suppose we have this for number 2. Let's see. Let's go ahead and write this one. So number 2, we have x minus 2 is less than 5x plus 2 is less than or equal to x minus 8. Okay? I'm sorry. Let's do x plus 8. Excuse me. X plus 8. All right. Now, notice I have this compound inequality. Every compound inequality can be solved by splitting it apart like we did here. So this compound inequality, I'm going to rewrite as 2 simple inequalities. So I'm going to say x minus 2 is less than 5x plus 2, and so it's that word intersection, and at the same time 5x plus 2 must be less than or equal to x plus 8. And so notice you're going to solve each of those simple inequalities. So for that one, let's go ahead and subtract x from both sides. And so x minus x is 0, so you get negative 2 is less than 5x minus x is 4x plus 2. Subtracting 2 from both sides, a negative 2 and a negative 2 is a negative 4 is less than 4x. See, this is 0. Divide both sides by 4. I get negative 1 is less than x. So the solution to this simple inequality is any number greater than negative 1. So negative 1 is less than x means x is greater than negative 1. So that's what I found. Okay? So now we're going to do the other one. So in the other one, we're going to solve this simple inequality. So I'm subtract x from both sides. 5x minus x is 4x plus 2 is less than or equal to, that's 0, so 8, right? Subtract 2 from both sides. I get 4x is less than or equal to 6. Divide both sides by 4. I get x is less than or equal to, and 6 divided by 4 is 3/2. All right? So any real number less than or equal to 3/2 is a solution to this inequality. But remember, I'm trying to find the solution to this compound inequality. So we got to think about it this way. So let's put 1 and 3/2 in the number line. So here's, negative 1. Here's negative 1. Here's 3/2. So the solution to this compound inequality is this. It's any real number greater than negative 1. So open circle to the right. That's this. And at the same time, any real number less than or equal to, close circle, to the left. Less than or equal to 3/2. And so it's the intersection of those two. That's the solution to this compound inequality. So therefore, your answer, in terms of the graph, it will be negative 1, 3/2. Negative 1 3/2. Now remember 3/2 is 1.5. So on the number line, be careful how you write it. So in the number line, you could see this: negative 1, 0, 1, 2. So make sure you put those in the right spot. So here's negative 1 with a open circle, and then 3/2 is 1.5. So make sure you put that in the right spot. So here's 1.5 and it's closed. Okay, so that's 3/2, and then shade everything between them. So it depends. It depends on the number line they give you. So make sure you, depending on the number line they give you, put it in the right spot. So this is 3/2. Usually, though, if it's just a number line with no numbers, you just put negative 1 3/2, open, closed, and shade in. All right. So if numbered line's given, make sure you put 3/2 in the right spot. The interval notation. You're going to say parentheses negative 1 to 3/2 with a bracket. Parentheses because it's an open circle, bracket, closed circle. And then the inequality will be, so your variable is x, so you're going to say x must be between, notice open circle, parentheses, closed circle, open circle, no equal sign, closed circle, equal sign. So x must be between negative 1 and 3/2. Okay? All right, so x must be greater than negative 1 and at the same time less than 3/2. That's what that says. Notice when you do the inequality, those symbols are pointing in the same direction. Okay, now you may ask, well, can I do the shortcut with this one? Look at the variables on the outsides. Are those variable terms identical? X, they're identical. So yes, you can do number 2 using the shortcut. So let's go ahead and do that also. So let's go ahead and rewrite this over. All right. So since the variables appear on the outside and they are identical, then I can subtract x from all parts, and that will eliminate the variables on the outside. And so x minus x is 0, 0 to negative 2 is a negative 2, it's less than 5x minus x is 4x, plus 2, it's less than or equal to, and then that's, 8? And now notice I went from this compound inequality to an easier compound inequality. The variable only appears in the middle, so I can easily get the variable by itself in the middle. Subtract 2 from all parts. Negative 2 to negative 2 is a negative 4. It's less than 4x. It's less than or equal to 6. And now dividing every part by 4 to get x by itself. All parts now. Negative 4 divided by 4 is a negative 1. It's less than x. It's less than 3/2. And notice the solution you see here is the solution you saw here. Okay, so these are the same. And so it's just a matter of you now, so here's your inequality. So it's just a matter of you now writing it as showing the graph. So here's negative 1, here's 3/2, open circle, closed circle. You're shading in every real number between those two, and there are infinite numbers of real numbers between negative 1 and 3/2. So there's your graph. And then interval notation. So your solutions are between negative 1 and 3/2. Since that's an open circle, you're going to say parentheses negative 1. That's a closed circle. You're going to say 3/2 with a bracket. So there's your interval notation. All right, so that was number 2. Okay, let's look at number 3. Number 3. So in number 3, let's suppose we had this one. So we have negative 2x minus 7 is less than negative 6x plus 5 is less than negative 2x minus 3. Okay? And so what we're going to do here is notice this is a compound inequality, and you can use both approaches. You can use a shortcut here because notice the outer terms are identical, negative 2x, negative 2x. So if you add 2x to all parts, you'll eliminate the variables. So you can do it both ways here as well. But let's go ahead and do the first approach. So I'm going to write this as two simple inequalities. So I have negative 2x minus 7 is less than equal to negative 6x plus 5. And at the same time, negative 6x plus 5 must be less than negative 2x minus 3. Okay? So to find the solution to this compound inequality, I'm going to solve each simple inequality individually. And then I'm going to look at the graph of each one and find out where they intersect, and that will be the solution to the original. So I'm trying to find all values of x that will make this expression less than equal to this expression, and at the same time less than this. All right? So I'm going to go ahead, to make it easier myself, I'm going to go ahead and add 6x to both sides. And by adding 6x to both sides, I get this. Negative 2x and 6x is 4x. Minus 7 is less than or equal to, and then we're left with 5. 6x and a negative 6x is 0. Adding 7 to both sides, I get 4x, that's 0 here, is less than or equal to, and then 7 plus 5 is 12. Dividing both sides by 4, I get x is less than or equal to 3. So any real number less than or equal to 3 is a solution to this simple inequality right here. We're going to do the same thing here. Now remember, that's only the solution to this. That's not necessarily the solution to the original, so you got to be careful. Over here, I'm going to go ahead and add 6x to both sides here. And so combined like terms, this is 0, so I get 5 is less than negative 2x and 6x is 4x minus 3. Adding 3 to both sides, I get 8 is less than 4x. This is 0. And so dividing both sides by 4, 8 divided by 4 is 2 is less than x. So the solution to this simple inequality is any real number greater than 2. All right? And so now to find the solution to this compound inequality, we're going to say this. So let's put 2 and 3 on the number line. So 2 and 3. So the solution to this compound inequality is any real number less than or equal to 3, closed circle to the left, and at the same time, and intersection, and at the same time must be greater than 2. Hence see where it says no equal sign, so open parentheses. So it's the intersection of those two. And so your answer for the graph, you're going to say 2, 3, open circle on 2, because it's an open circle, closed circle on 3, and then shade in everything between them. Your interval notation, you just read the graph from left to right. So open circle, that's parentheses, 2, comma, 3, closed circle means bracket. So your solution would be any real number between 2 and 3, not including 2. 2 is not a solution, but 3 is. So hence, that's why you see parentheses and then the bracket. And so your inequality, now you got to be careful when you write that. So your variable is x, so you're going to say x, so all your x's must be between 2 and 3. So 2 is the smallest, and less than, so 2 is less than x, no equal sign because of the open circle. You can even see that here. And at the same time, x must be less than or equal to 3. Okay, x must be less than or equal to 3. All right, so that is your solution to this compound statement. Now, if you wanted to use a shortcut, this is what you would have. So let's quickly do that. So this is number 3 with the shortcut. 2x minus 7, that's second approach. Make sure I'm writing this correctly. Okay, so since the variables on the outside, on the outer parts are identical, the variable terms, then I can eliminate those variable terms by just adding 2x to all parts, all three parts. Combining like terms, negative 2x and 2x is 0, so you're left with negative 7 is less than negative 6x and 2x is a negative 4x plus 5 is less than, this is 0, negative 3. So now went from this compound inequality to an easier compound inequality. And to get the variable term by itself, we're going to go ahead and subtract 5 from all parts. Negative 7, negative 5 is a negative 12. It's less than or equal to, this is 0. And you're left with negative 4x is less than, and then negative 8. All right, now be careful with the rest of this. See, this coefficient of x is negative, so you got to remember some things about dividing or multiplying an inequality by a negative number. So to get x by itself, I'm going to divide all parts by negative 4. But you got to remember, when you multiply or divide an inequality by a negative number, you have to reverse those inequality symbols. So negative 12 divided by negative 4 is 3, is greater than or equal to, this is going to be 1x or just x, is greater than 2. So notice I divided by negative, so these inequality symbols reversed. So notice they're pointing in the same direction, greater than, greater than. When you draw the graph, though, make sure you put this in the correct order. 2 must be listed first, and then 3 is second. Sometimes this confuses students, so what you may want to do is to rewrite what you see here. So 3 is greater than or equal to x is greater than 2 is the same thing as saying, going backwards, that 2 is less than x is less than or equal to 3. So those are the same things. So notice that this is a lot easier for students to visually see when they graph. So open circle on 2, there's no equal sign. Closed circle on 3, because there's an equal sign. You're going to shade in everything between them. So every real number between 2 and 3, including 3, but not including 2, is a solution. And as an interval notation, you're going to say parentheses 2, comma 3 with a bracket. Okay? All right, so that was a shortcut. All right, but be careful when you divide by a negative number. You got to remember to the reversal of those inequality symbols. Okay, so let's look at number 4. Number 4. In number 4, let's suppose we had this. 3 plus x is less than 6x minus 7 is less than 5x minus 1. Okay, now, this is the situation where you cannot use this second approach. This approach here only applies if the variables on the variable terms on the outer parts are identical. If you notice in number 4, this variable term is x and this variable term is 5x. They are not identical. So the only way you can do this is to use that first approach. That's the only way. All right, so let's go ahead and do that. 3 plus x is less than 6x minus 7, and at the same time, 6x minus 7 must be less than 5x minus 1. All right, so the only way you can do this one is using that first approach only, since the variable terms on the outside are not identical. This is x, this is 5x. Okay, so now we're going to solve each simple inequality individually. So let's see, it's easier to bring the terms to the right side. So I'm going to subtract x from both sides. So this is 0 when I combine like terms. I get 3 is less than 6x minus x is 5x minus 7. Adding 7 to both sides, that's a 7 here. Adding 7 to both sides, I get 3 and 7 is 10 is less than 5x. This is 0. Divide both sides by 5. I get 5. 10 divided by 5 is 2 is less than x. So the solution to this simple inequality is any real number greater than 2. So 2 is less than x means x is greater than 2. Okay? So that's the solution to this first one. That's not the solution to the original, to this compound one. You got to be careful because you got to look at this one and then look at the intersection. Now let's do this one. So since the coefficient of x here is bigger than the coefficient of x here, I'm going to bring the variable terms to the left-hand side. So I'm going to subtract 5x from both sides. So 6x minus 5x is x, minus 7 is less than negative 1. Adding 7 to both sides, I get x is less than 6. Okay? Now, x is less than 6, so any real number less than 6 is the solution to this. Now, to find the solution to the compound inequality, that's where we look at each of those individually and look at the intersection. So put them in order, 2 and 6. So this says that x must be greater than 2, and then this says x must be less than 6. So notice they're both open circles, and the solution to the compound inequality is the intersection of those two. And so the intersection of those two, so your graph, so this will be your answer. Your graph will be 2, 6, open circle on both. So any real number between 2 and 6. So for example, 3.87 is a solution, 2.0006 is a solution, let's say 10 divided by 3 is a solution, things like that. So any real number between 2 and 6. All right, that's a 6. Okay, now your interval notation. So as an interval, you're going to say parentheses 2 all the way to 6 with parentheses because of the open circle, so that's why I use parentheses. 2 and 6 are not solutions, so you have to use parentheses. And then your inequality, now be careful how you write that. So in your equality, all your x's, and this is a variable x, so you can say all your x's must be between 2 and 6. Notice that they're both parentheses, so you're going to use the inequality less than. So 2 is the smallest and 6 is the largest. So any real number between 2 and 6. So your x must be less than 6, that's what this says. And at the same time, the 2 must be less than x. That's what this says. Okay? All right, so that's number 4. So notice no shortcut here. You can't do that second approach because the variable terms on the outsides are not the same. And then finally, let's do one more. So this will be number 5. Number 5. So let's say number 5, we had this, number 5. All right, we have 2x minus 3 is greater than 3x plus 4 is greater than x minus 20. All right, so we have this compound inequality. Notice the variable, the inequality pointing in the same direction, greater than, greater than. Notice, so the question becomes, can you use that second approach to where you can get the variable in the middle by itself? The answer is no. Because look, on the outer terms, this term, the variable term here is 2x. The variable term here is just x. Those are not the same. They're not the same term. So you are going to have to split this apart into two simple inequalities. So you're going to say 2x minus 3 is greater than 3x plus 4. And at the same time, 3x plus 4 is greater than x minus 20. And so to solve this compound inequality, you're going to solve each of those individually first. So since the coefficient of x here is greater than the coefficient of x here, let's go ahead and bring the variable, the variable terms to the right-hand side. So subtract 2x from both sides. This is 0, so I got negative 3 is greater than x plus 4. 3x minus 2x is x. Subtract 4 from both sides. Negative 3 to negative 4 is a negative 7 is greater than x. Okay? Now, remember, your solution is any, so negative 7 is greater than x means the same thing as x is less than negative 7, right? That's what that means. So any number less than negative 7, any real number less than negative 7 is a solution to this simple inequality. Now let's do this one. So I'm going to subtract x from both sides here. So 3x minus x is 2x plus 4 is greater than negative 20. That's 0. Subtracting 4 from both sides, I get 2x is greater than negative 24. And then dividing both sides by 2, I get x is greater than negative 12. So any real number greater than negative 12 is a solution to this. But I'm interested in the solution to the compound inequality, because that's where You got to look at each one individually and then look at the intersection. Okay, so let's put -7 and -12 in the correct order. So -12 is smaller than -7, so make sure you put those correct. So the solution to the compound statement is this: any number, any real number less than -7 and at the same time must be greater than -12. And those numbers that work are the intersection of those two graphs. And so your answer will be this. So here's your graph. -12, -7, open circle, shade between them. Your interval notation will be parentheses -12 all the way to -7 parentheses. And then your inequality, just make sure you write that correctly. Your inequality, this says that all your solutions are between these two numbers. So you have -12, -7, you have x in the middle, and then so now you got to put the inequality symbol. So x must be less than -7, and at the same time -12 must be less than x. And that's it. So that is, and you cannot use a shortcut here because the variable terms on the outside are not the same. So that is the steps to solving a, let me find the first page. That's the steps to solving compound inequalities where you have variables on all parts.